Introduction to inverses. An inverse relation is a set of ordered pairs that is the result of swapping inputs and outputs in a relation. Here are two examples. If this is the map of S, this is the map of S's inverse. We've just swapped the outputs with the inputs like so. Example B. If this is T, this is T's inverse. An inverse relation is the result of swapping inputs and outputs in a relation. Example A continued. Here are the properties of inverses that deserve attention. 0, 2 belongs to S implies that 2, 0 belongs to S's inverse. So this point here, 0 maps to 2, therefore 2 maps to 0 is in the inverse. The domain of S equals the range of S's inverse. So 0, 1, 2, and 3 are in the domain of S, and they are the range of S's inverse. The domain of S's inverse, 2, 5, 8, 11, equals the range of S. In this example, both S and its inverse are functions. For each input, there is one output, and for each output, there is one input assigned to it. Example B continued. True or false? -1, 2, so this point right here, -1 maps to 2, belongs to T, implies that 2, -1 belongs to T's inverse. That is true. We see that right there. True or false? The domain of T equals the range of T inverse. That is also true. The domain of T inverse equals the range of T. That is true. T is a function. Well, each input maps to exactly one output, so that is true. T inverse is a function. This is false because we have one input here that maps to two different outputs, so the inverse is not a function. They were all true except for the last one. Summary. Here are the properties of a relation S and its inverse relation. If A, B belongs to S, then B, A belongs to S's inverse. The domain of S equals the range of S's inverse. The domain of S inverse equals the range of S. If a relation is a function, its inverse relation may or may not be a function. In example A, the relation and its inverse were both functions. In example B, the relation was a function, but its inverse relation was not a function.